Welcome to Lecture 11, Trigonometric Substitutions. Okay, so let's give a quick overview. The big idea here is some integrals don't involve trig functions, but they require trig substitutions. You can try it, but you'll notice that U-Substitution is not going to work. Okay, so what do? Here's a table of what you do. And before I explain the table in too much detail, I want to do an example so you'll see, to get some motivation. Now I know this looks intimidating, but let me just say that these three things are what you need to memorize. So you look at this, you say, hey, look, there's a root 4 minus x squared. That has the same form as this. So my first step is to substitute x equals a sine of theta. And a, of course, here is 2. Now this range and this back substitution, you don't need to memorize that. This is what's going to happen when you do the substitution. It's not something you have to learn or you have to memorize. It'll just fall out. Okay, so let me try to motivate this first. Well, let's say that the goal of this is to convert the expression under the square root. So this a squared minus x squared, the goal is to convert that into a perfect square so you can take the square root easy. And so to motivate this, in this example, let's suppose that if x equals a sine of theta, then a sine of theta squared plus a cosine of theta squared equals a squared. So in this case, a cosine of theta is the square root of a squared minus a squared sine squared of theta. And notice, when you make this substitution, this square root here is going to turn into that right there, which looks even worse until you realize that is just equal to a cosine theta. And that is going to greatly simplify your integral right here. So what makes this work is just the fact that sine squared plus cosine squared equals 1. And what's going to make these work is the fact that there's a similar identity involving secant and tangent, which honestly, I don't remember that one. I have to rederive it every time. So let me show you. What's behind everything here is the fact that sine squared of theta plus cosine squared of theta equals 1. Again, that's something you should have memorized. And then the secondary formula, which again I never have memorized, but I know I could just rederive it by taking this equation and dividing every term by cosine squared of theta. So if I do that, I get tangent squared of theta, that's sine over cosine, plus 1 equals secant squared of theta. So this equation is going to be behind in the same way how this substitution made this square root turn out nicely. These substitutions are going to make these square roots turn out nicely. Okay, so this is so I want you to think about this in the back of your mind. Just be aware of it when you're seeing me do this example. Okay, so let's do the example. So as suggested by the table, I'm going to make a substitution. I'm going to let x equal 2 sine theta. And now here I can't let this happen for all theta. So technically I need to let theta be between negative pi over 2 and pi over 2. And on the unit circle, that is this region. Let's see. So that is this region right there. Okay. So if we make the substitution, then dx equals 2 cosine of theta d theta. And if we substitute this back into the integral, this integral becomes, let's see, so x squared. On top we have 4 sine squared theta, and on the bottom we have 4 minus 4 sine squared theta. It's a sine squared theta. And then my dx is 2 cosine of theta d theta. Okay, so a few things here are going to simplify. Well, this 2 is going to cancel, so we can pull out this square root of 4 outside. That's going to cancel with this 2. Well, it's not much of a simplification, but let's just write that. So this is the integral of 4 sine squared of theta over 1 minus sine squared of theta times cosine of theta d theta. And again, that 2 is going to cancel with these two 4's. So remember, the key here is this thing here is going to be the square root of cosine squared of theta. So that's just going to be cosine, and that's going to cancel with that cosine. So let me write this out as the integral of 4 sine squared theta over, well, technically I should say this is the absolute value of cosine, because if I square it and then take the square root, I end up with the absolute value, not necessarily cosine. So that presents a potential difficulty, but as we'll see, it's not bad. So cosine theta d theta. And now what I want you to notice is that I chose this domain. So cosine of theta on here. So cosine of theta is greater than or equal to 0. And if that happens, then this is equal to just plain old cosine. And so I can cancel it with that. And should I? Yeah, let me say as a note. The square root of cosine, I think it's worth saying, the square root of cosine squared is cosine of theta, an absolute value, which is equal to cosine of theta, if we're assuming that negative pi over 2, or theta is between negative pi over 2 and pi over 2. Okay, so there's this integral we have. This thing simplifies greatly down to the integral of 4 sine squared of theta d theta. And we know how to do this from the previous lecture. Let me pull out the 4. I always like to do that. 4 times 1 minus cosine of 2 theta over 2 d theta. And this is, well, what should we do with this? Let's write this as 2 times the integral of d theta minus 2 times the integral of cosine of 2 theta d theta. Okay, so this is something we can do. Well, so one of the disadvantages of an online lecture is I don't have 3 or 4 blackboards of space that I can fill up and point to at the same time. So let me summarize the information, at least the key information. Remember, we let x be 2 sine of theta. Let me box that. And the integral that we left off with was equal to, it was 2 integral of 2 theta, that's easy, minus 2 integral of cosine of 2 theta d theta, that's also easy. So we need to do a quick U-Substitution. Let u equal 2 theta, du equals 2 d theta, so d theta equals 1/2 du. Okay, great. So this first term is 2 theta. This second term is minus 2 times the integral of cosine of u over 2 times du. The 2's cancel. And I get 2 theta minus sine of u, is that right? Yes, plus c. And so back substituting, I get 2 theta minus sine of 2 theta plus c. Okay, so I still need to go back to x. Theta was not my original variable, so I need to back substitute once again. And this here, first of all, I'm going to use a double angle formula to get rid of sine of 2 theta. I want to write everything, as we'll see, in terms of sine theta, cosine theta. So this thing, remember, there's the double angle formula. This is equal to 2 sine theta. This is one of the double angle formulas anyways. There's several of them. Cosine theta. So if I make that substitution, this integral becomes 2 theta minus 2 sine theta cosine theta plus c. So we just have to substitute back in for theta. And notice up here, we know what theta is. Theta is arc sine, or sine inverse, of x over 2. And remember that last column I said involved back substitution on a couple pages ago, and I said don't memorize it. It's going to come out. This is what I mean by it. It's going to come right out. Okay, so what we got to do is, so this, I guess this is theta. One thing, let me show you something that's not going to work very well. So one thing I could do is I could write this as 2 inverse sine of x over 2 minus 2. Now if we plug inverse sine in for, so sine of inverse sine of x over 2, that's going to be 2x over 2. That's because this inverse sine and sine are inverse functions. But then we're going to have to plug inverse sine in for cosine, so we're going to get cosine of inverse sine of x over 2. And that's, well, while that's certainly true, we can do better than this. This can be greatly simplified. Okay, so to show you a better way to do this, let me draw a triangle motivated by this fact right here. Let x be equal to 2 sine of theta. So I'm going to draw a triangle with angle theta and radius, or with hypotenuse 2. So if this is theta, and I'm going to draw a triangle like this for all three of those cases that I showed you a few slides ago. No matter which trig substitution, this 2 here, that's going to be my radius, so my hypotenuse. So this is going to be 2, and x is 2 sine theta, so that is x. Now if I do this last side, by the Pythagorean theorem, is square root of 4 minus x squared. Now things should be coming together. So this here is 2 sine of theta, whereas this term is 2 cosine of theta. Remember, the sine is this length, and the cosine is going to be that length. Well, I guess 2 times the sine and 2 times the cosine. That's just basic trig. So now we just say that we can say that cosine of theta, this was our problem thing here. So cosine of theta equals square root of 4 minus x squared over 2. And this is what we want to, this is what we needed to back substitute that was in that right column of the table that I said don't memorize. It's going to fall out just like this. I do not have it memorized exactly the form that this thing is and where the square root is, and it was at a squared minus b squared is a cosine. I just know if you draw the triangle, it's going to come out. So now I can, I'm getting a little messy here, but let me box the last good thing that I had. This is bad. So this last good thing that I had, I can now I can write this as 2 inverse sine of x over 2. Oh, that was okay from here. But now I have minus 2 times x over 2. Let's make sure that minus does not look like a dot. And the cosine of theta becomes square root of 4 minus x squared all over 2 plus c. So let me slightly simplify this. And this is now 2 inverse sine of x over 2. Let's see, the 2's cancel. So minus x square root of 4 minus x squared over 2 plus c. And there is our final answer in a much better form than what we had up here. Okay, and that is that. So one warning, as you've noticed, trig sub takes time. This is the most difficult method that we've seen. It's definitely the longest and the tedious. So use it as a last resort. You know, if there's a faster method available, do that. For example, something like this. Well, you look at this and your first thought might be, using that table that I asked you to memorize, one thing you could do is you could say, well, let x equal 2 tangent of theta. And then you could proceed. This will work. But it's going to be messy. What you should do first is see, does anything else work? And in this case, U-Substitution is going to work. And you should always try that first. So let me not do that. Let me let instead u equal to x squared plus 4. So du equals 2x dx. And let's see what happens. So if that happens, so this integral, I think this will work. Yeah, so the bottom of this integral becomes the square root of u. The top of the integral, what happens here? So let's see, we have, well, yeah, I thought something would work. Let me check about this. Maybe, well, let's do it step by step. I think this will work. So over here, dx equals, what does dx equal? 1 over, or du over 2x. So let's just plug in what we have. So here we have x cubed. Here we have du over 2x. And now what's gonna, well, this may or may not work, but let's just keep trying. So we're gonna get a 1/2 times an x squared over square root of u du. And hey, look at this. It does. So x squared, that we can write that in terms of u. We can write this as 1/2 times the integral of u minus 4 times square root of u du. And well, let's finish the integral because we're close. Yep, and now we can do 1/2. Let's break this into two parts. So 1/2 times the integral. So this is u to the first over u to the half. That's u to the 1 minus 1/2. That's u to the 1/2 du. And then minus 1/2. Well, let's see, there's a 4 there, so let me pull the 4 out. So minus 4/2 times the integral of u to the minus 1/2. So you should be able to do this, but since we're close, let's finish it. So this first one is 1/2 u to the 3/2 over 3/2 minus 2 u to the 1/2 over 1/2 plus c. So this is, so 1/2 divided by 3/2 is 1/3 u to the 3/2 minus 2 divided by 1/2 is 4, so 4 u to the 1/2. And if we substitute back in, this is 1/3, I forgot my c up here, 1/3 x squared plus 4 to the 3/2. So that's, well, let's just write 3/2. We could do cubed and a square root if we want to, but we don't need to. Minus 4 u to the 1/2. Okay, here I'll do a root x squared plus 4 plus c. And there is our answer, which was not at all obvious that U-substitution was going to work, but we tried it and it did, and fortunately we avoided trig sub.